Welcome back to our continuing discussion of the array list, the need to override equals. Remember, all classes ultimately inherit from object. Object has default implementations. The toString method just prints the class name plus the heap location of the object. Equals just falls back to reference comparison. It regards two objects as being equal if their location in memory is equal. This is known as a shallow comparison. For these methods to work for classes, we need to override the default methods, especially in our application. Let's take a look back at our application. Notice, when I added these students to the array list, I create a new object, a new student object, 5 of them. Object ID 10, 20, 30, 40, and 50. When I want to remove, and notice here, I can't just specify remove 30, because that would be interpreted as a remove with the index ID 30, the index location 30, not the student ID 30. So in order to remove by value, I need to create a new student object. Well, consider reference comparison. Reference comparison says two objects are equal if their memory location is equal. Well, this in fact is a new student record we've created on the heap, just with the ID specified, so the first name and last name remain empty. That will never be equated with this, because the two memory locations are different. So when we remove it, remove within its default implementation finds no student with the same memory location. So the equals method that I added here only cares, remember, it only cares about the ID being equal. In fact, it's engineered for this specific location. Let's run it. You can see the results here. Now, if you're paying attention, you've noticed I've modified my toString method a little bit. I wanted to add the ID here, and we see the previous student, ID 30, and now we've successfully removed it. So remove is actually now calling our equals method. It calls back to it and says, does this equal? Does this equal? Does this equal? Yes, it does. And it removes it and it's finished. Okay. It's doing a deep comparison now. It's not just comparing memory location, because we've overridden the method that we inherited from object to be meaningful in our case. Namely, we want to find the ID and remove it by that. That's our equality. Do we always need to override objects methods? No. Classes that are designed to be deep workers, far away from the UI, are less likely to need custom toString or equals. So objects that are closest to bubbling up to the UI, like students, like employees, those are things that are generally represented on a UI. They typically do need to override toString and equals methods in order to work properly, both for display and for collections in general, not just array lists. So it is very important to understand when to do it. If you have for example, a class that just connects to a database or does some mathematical computations for you, it's not connected directly to the UI. It never bubbles up where a person can see it. It's less likely to need an equals method or a toString method. All right, now we're ready for ArrayList Challenge 4. So we're going to use collections.sort on students to sort the students by last name. The Java compiler will object to this. A student must implement comparable student, and sort needs to know less than, greater than, or equal to. So let's take a look at our code. Now I've modified mine a little bit already. So I have collections.sort on students. I print out sorted, and then I'll print out the sorted students. We see a compiler error in student, and I've implemented comparable here, at least I've declared it. Now remember, this is an interface. Comparable is an interface. When you have the implements, that means you're implementing an interface. In this case, comparable. That means I'm going to make the student objects comparable with one another. If you think about what sort needs, sort is a very sophisticated array sort method to put objects in sorted order, but there's no way that sort would know our business needs. So we need to tell it, how we do less than, equal to, or greater than. Equal to is the equals method that we implemented earlier is not enough for sort. It needs those three states to say, as it goes through the array list, putting things in sorted order, it needs to know whether objects are less than, equal to, or greater than in order to put them in the sorted order that we need for our business purposes. So I hope you can anticipate the compiler error here. We haven't implemented those methods yet. We've promised to implement them. That's what an interface does, but we haven't implemented it. And here we'll go ahead and do it. And we have now added the compare to method that we promised in the comparable interface. In other words, comparable says, I'm a class that knows how to compare instances of objects to one another. In this case, we'll always return 0. So I paused the recording momentarily to add these comments. -1 means less than, 0 means equal to, and 1 means greater than. So this compare to method is always going to say that it is equal to. So since it's always equal to, sort does nothing. It's viewing when it calls to compare to, compare to is saying every object is equal to every other object. Therefore, sort has nothing to do. So the real challenge here is get compare to work for the purposes described. That is, put this list of students in alphabetical order according to last name. Now pause the video and see if you can do that. Here's my solution. So -1 means less than, that is this, the current object. 0 means equal to, or 1 means greater than. So my solution takes advantage that last name, or string, the string class implements comparable. Therefore, it's guaranteed to have a compare to method. A little bit of the power of interfaces. You can depend on the method being there. So last name compared to o.lastname. So this, the current object, compared to o.lastname. And we can see the result of running it. Here's my initial list, then my list with ID 30 removed but not sorted. And here's my list finally sorted by last name. All right, in the next lecture, we'll see how to sort your list from a variety of ways. So comparable says, I know how to compare student objects, but you can only have one method to do that. So one sort routine. Well, what if you need to sort your objects in a variety of ways? By last name, by first name, by ID. In the next lecture, we'll see how to do that.